Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC B1176 pertains to the fuel level sensor circuit short in the Honda Civic models from 2006 to 2011. This error is related to the fuel gauge sending unit, which is responsible for transmitting the fuel level data to the engine control unit, ECU, and subsequently to the fuel gauge on the dashboard. The fuel gauge sending unit is generally located within the fuel tank assembly, and it plays a crucial role in ensuring that the driver is accurately informed of the fuel levels. When a short circuit occurs within this sensor circuit, it can lead to erroneous readings, causing the fuel gauge to malfunction. Understanding this DTC is essential for proper diagnostics, as it can significantly impact fuel management and vehicle performance. In the troubleshooting guide, we'll explore the potential causes, symptoms, and detailed steps to address this issue effectively. The fuel level sensor, also known as the fuel gauge sending unit, is an essential component within the fuel tank assembly of the Honda Civic. Its primary function is to accurately measure the amount of fuel present in the tank and send this information to the vehicle's engine control unit, ECU. The ECU then relays the data to the fuel gauge located on the dashboard, informing the driver of the fuel level in real time. A short circuit in this sensor's wiring can disrupt its function, leading to incorrect fuel level readings. The sensor operates in conjunction with other components and relies on precise electrical signals to perform effectively. When diagnosing DTC B1176, understanding the location and role of the fuel level sensor is critical for efficient troubleshooting and repair. There are several potential causes for DTC B1176 being triggered in a Honda Civic. A primary suspect is a short circuit within the wiring that connects the fuel level sensor to the vehicle's ECU and fuel gauge. This electrical fault can lead to improper signals being sent, causing erratic gauge behavior. Additionally, a faulty fuel gauge sending unit itself may fail, leading to incorrect readings. Loose or poor connections within the circuit could also lead to intermittent signals, triggering the DTC. Lastly, if the gauge control module experiences issues, this could negatively impact the communication between the ECU and the fuel level sensor, resulting in erroneous readings. Each of these factors requires careful examination during the troubleshooting process. When DTC B1176 is present, several symptoms may arise in the vehicle. The most prominent symptom is erratic fuel gauge readings. Drivers may observe the fuel gauge fluctuating unexpectedly or remaining stuck on empty, despite the tank being filled. In some situations, the check engine light could illuminate, indicating a fault in the vehicle's diagnostic system. This artificial representation of fuel levels can lead to confusion and may leave the driver unaware of an actual fuel issue. Additionally, notifications regarding fuel levels can become unpredictable, creating risks of running out of fuel unexpectedly. Recognizing these symptoms early can assist in addressing the DTC promptly and ensuring vehicle safety. The first step in troubleshooting DTC B1176 involves utilizing the Honda Diagnostic System, HDS, to clear the diagnostic trouble codes from the vehicle's ECU. By doing so, you reset any existing error codes associated with the fuel level sensor circuit. The HDS is a specialized tool designed for Honda vehicles, allowing technicians to access various diagnostic features. After clearing the DTCs, you should turn the ignition switch to the lock 0 position and then back to on 2. This process helps align the ECU's data with the current operational status of the vehicle. It is essential to ensure that the vehicle is prepared for accurate diagnostics by resetting any previous faults, prior to further investigation. In the second step of the troubleshooting process, you must ensure the ignition switch is turned to the lock 0 position and then returned to on 2. This step is crucial for reinitializing the vehicle's systems, allowing the ECU to properly recognize the changes after DTCs have been cleared. Once you have turned the ignition back to the on 2 position, it is important to wait for at least 30 seconds. This waiting period allows the system to re-establish communications and check for any persistent issues. By adhering to this step, you minimize the risk of overlooking other potential problems, which may affect further diagnostics. Once this waiting period is complete, you can proceed to the next critical phase of the troubleshooting process. After waiting for the designated 30 seconds, the next step is to check for any reoccurring diagnostic trouble codes using the Honda Diagnostic System HDS. This step is vital, as it informs whether the earlier issue with the fuel level sensor circuit persists. You need to determine if DTC B1176 is indicated again. If it is present, it suggests that the initial issue has not been resolved and further investigation is warranted. However, if no DTCs appear, it could indicate an intermittent failure, suggesting that the fuel level sensor circuit might be functioning properly at that moment. Should B1176 be indicated again, proceed to the next troubleshooting step to further pinpoint the issue at hand. In this step, start by turning the ignition switch to the lock 0 position once again. This is necessary to safely disconnect components without causing further electrical issues. Following this, you will disconnect the fuel tank unit's 4P connector, which connects the fuel gauge sending unit to the vehicle's wiring harness. Inspecting this connector is vital, as it can be a potential point of failure. Poor connections or corrosion at the terminals may lead to abnormal readings or shorts in the circuit. Once you have made this disconnection, you can proceed to the next steps of clearing DTCs once more and checking for indications of the problem. Evaluation of the 4P connector can provide insights into the health of the fuel level sensor as well. Once the fuel tank unit's 4P connector has been disconnected, the subsequent step is to clear DTCs again using the Honda Diagnostic System HDS. This is a necessary preparation for accurately monitoring the circuit's behavior without interference from any previous error messages. Disconnecting the connector allows for a more focused examination of the fuel gauge sending unit. Once cleared, you will turn the ignition switch back to lock 0, and then return it to on 2 again. This reinitialization process further enables accurate diagnostics by removing any potentially misleading error conditions. Following this, you should allow the system to stabilize and be ready for the next step of checking for DTCs. After allowing the system to stabilize with the ignition set to on 2, the next step is to check for DTCs once more using the Honda Diagnostic System HDS. Monitoring the system now allows you to ascertain if DTC B1176 is still indicated. If the code appears again, it confirms that an issue remains and further diagnosis is necessary. However, if the code does not reappear, it suggests that the problem may lie within the fuel gauge sending unit itself. In either case, understanding the next course of action is essential, whether it involves further troubleshooting steps or leading to component replacement. Being methodical in this step ensures the diagnosis is thorough and accurate, preventing unnecessary part replacements. In this step, if DTC B1176 continues to indicate, the next logical action is to reconnect the fuel tank unit's 4P connector. Ensuring that all connections are properly made at this stage is vital to maintain circuit integrity and function. Following the reconnection, you must turn the ignition switch to lock, 0, and then prepare to check the gauge control module. This step is significant because the gauge control module is crucial for interpreting and processing signals from multiple sensors, including the fuel level sensor. Any faults within this module could directly influence the behavior of the fuel gauge, leading to erroneous readings. Proper attention to details during this connection is necessary to avoid issues arising from poor contact points. At this phase of troubleshooting, you will turn the ignition switch to lock, 0, once more in preparation for disconnecting the gauge control module, specifically the 36P connector. This module communicates with the fuel gauge and other critical dashboard readings, making it a vital component in managing displayed information. A thorough inspection of the 36P connector is essential, as any faults or breaks in this wiring can cause communication breakdown. This disconnection serves as a method to isolate the gauge control module from the system, allowing for further diagnostics. Following this, you will need to conduct electrical tests to ensure continuity, which is necessary for determining the presence of any underlying problems within the connections or the module itself. This step involves checking for continuity between terminal number 32 of the gauge control module's 36P connector and the vehicle's body ground. Continuity tests are crucial in diagnosing electrical faults, as they allow you to determine whether electrical signals can be transmitted effectively through the circuit. If continuity exists, it indicates that there is no break in the circuit and further points towards a short to ground in the wire leading to the fuel tank unit as the possible cause of the DTC. On the other hand, if continuity is absent, this suggests a potential fault within the gauge control module itself, necessitating its replacement. Ensuring accurate measurement and reading during this test is essential for effective troubleshooting outcomes. If your continuity test confirms a connection between the gauge control module's terminal and grounding, repairing the identified short to ground in the wiring is the next step. Addressing grounding issues is essential, as shorts can create erratic electrical signals, leading to misinformation relayed to the fuel gauge. During this repair process, you should closely inspect the wiring for frays, breaks, or corrosion that may contribute to the short. Ensuring proper integrity of all connections is paramount to prevent further issues down the line. Once repairs are made, retest the system to ensure that the DTC does not return, confirming that the issue has been adequately addressed. This step is vital in upholding the performance and reliability of the fuel level sensor system. If your continuity test does not show any connection, it may mean that the gauge control module itself is faulty. The next step is to replace the gauge control module, which is crucial for accurately interpreting the signals from the fuel level sensor and other components. Ensuring that the new module is compatible with the vehicle specifications is crucial for optimal performance. After replacement, it is important to test the electrical components thoroughly to confirm the system's functionality. This comprehensive testing ensures all related systems work harmoniously, providing accurate readings on the dashboard. Properly addressing this final component is essential for preventing further future errors or inconsistencies that affect vehicle operation. After completing all necessary repairs and replacements, it is essential to conduct a final repair verification. This involves testing the fuel gauge's functionality to ensure that it accurately reflects the fuel level in the tank. Observing the gauge during different fuel levels is crucial for confirming its performance. Additionally, you should perform another check using the Honda Diagnostic System, HDS, to verify that no diagnostic trouble codes are present, particularly DTC B1176. Ensuring that the gauge is operational and that no codes returned provides assurance that the repair was successful. This final step solidifies the maintenance process, ensuring that the vehicle operates reliably and efficiently moving forward. To prevent future issues related to DTC B1176, implementing a routine preventive maintenance schedule is vital. Regularly inspecting the fuel level sensor can help catch any signs of wear or damage before they lead to significant problems. It is also important to check the wiring for any frays, breaches, or corrosion that could lead to shorts or miscommunication of signals. Cleaning all electrical connections helps maintain proper conductivity and ensures reliable operation of the fuel gauge system. By cultivating these maintenance habits, drivers can minimize the likelihood of encountering DTC B1176 again, while enhancing the overall longevity of the vehicle's performance. Taking a proactive approach negates potential issues and extends the life of vital components. In conclusion, understanding DTC B1176 and its implications for the Honda Civic models from 2006 to 2011 is critical for maintaining the vehicle's performance. Being able to identify symptoms early leads to timely repairs, thereby preventing further complications related to the fuel gauge and sensor functionality. The troubleshooting steps outlined provide a clear path for diagnosing and addressing the identified issues systematically. Moreover, the emphasis on preventive maintenance underscores the importance of regular checks to secure proper vehicle operation. Thorough diagnostics ensure that no underlying issues remain unaddressed, ultimately leading to a more reliable and efficient vehicle for daily functions. A proactive approach fosters driver confidence and safety on the road. Please like and subscribe to the channel. See you next time.